أبناءنا طلبة الشهادات العامة، تابعوا معنا أقوى وأمتع البرامج التعليمية بأحدث التقنيات الحديثة والإخراج المتميز على باقة قنوات المحروسة للشهادة الابتدائية والإعدادية والثانوية العامة ومدارس اللغات والإعدادية الأزهرية والثانوية الأزهرية. تابعونا نضمن لكم النجاح والتفوق بإذن الله.
Hello my dear students, welcome to our program today in chemistry, third secondary stage.
It's nice to meet you for this wonderful lesson. Let's go. Let's follow chapter 2. We will talk about the chemical analysis. Part 5. Let's see what we have. The first.
So we have here the quantitative analysis. What's meant by quantitative and what are the steps? Let's go to see.
As a beginning, volumetric analysis. It's a part of quantitative element analysis, so you must take it as a steps. Let's see the first.
So here we have what we have, displacement reaction. So it can be used to compare to reactivity different metals. We have some chemical reaction that's happened here. So here we have the copper sulfate as we have, and we have number 1, we have this one, play the step number 1.
If magnesium metal is added to a blue solution of copper sulfate, the blue solution color of the solution disappear. Do you think that? I think, yeah. Look at this. Magnesium is added and you wait for a time. Notes, tell me what happened now.
Here we have the metal turns an orange to pink color. Orange pink color, we have the chemical reaction that happened between the magnesium and the copper sulfate. So this is the displacement reaction between the metal and the solution.
So let's complete. Magnesium is more reactive metal than copper. And so the magnesium displaces the copper. Sure, from where? From blue copper sulfate solution, causing the blue color disappear, completely disappear. Then we can say
copper sulfate plus magnesium as reactants, and we have the product are magnesium sulfate plus copper. So the symbolic reaction will be
symbolic here. Copper sulfate CuSO4 plus magnesium. The product directly will be MgSO4 plus copper precipitate. What happened now?
So here we have the other one or other part of this reaction. We have the displacement like this of it is exothermic that gave the heat energy, and we have the replacement of magnesium with copper in this solution to give what? To give the red color of copper. So the reactivity differ from metals can be compared by comparing the temperature changing in reaction.
So the reaction is not enough like this. We must complete it and measure the temperature. It's high. Directly you say this reaction exothermic. When you add pieces of magnesium again to the solution, notice what happened for this reaction. We wait, add thermometer, temperature here increase. It will be 40. Do you think what this mean?
This mean the reactivity of different metals can be compared by comparing temperature changing the reaction. Why? Because we have different materials that make different degrees or different temperature of the exothermic reaction or endothermic reaction.
Exothermic here we know because the temperature increase. So this reaction followed by generation of heat. See another one.
We have here the test for carbon dioxide. So the carbon dioxide here we have what? We have this one. We have calcium carbonate, we have the hydrochloric acid, and here we have lime water. So when carbonates react with acid, carbon dioxide is produced. Why? We have what? We have this reaction here. So here, this is the first thing we have. Step number 1.
When the acid is added to the calcium carbonate, the bubbles of the gas evolve. I want to ask what is the name of these bubbles. Directly we say it's a carbon dioxide. I think that it changed the lime water into cloudy or milky. Now, this shows that the gas is carbon dioxide. Do you think that?
Yes, we have carbon dioxide. Why? Because we have here the changing of lime water into milky color or into cloudy color. But here we have the carbon dioxide that makes this reaction to form the calcium carbonate that doesn't dissolve in water here. So here we have the carbon dioxide test. It's like this.
Now, this method is based on measurement of the volume of the substance. Why? To be analyzed. It's great to know that. And also
it is based upon the measuring of amount of reagent of the concentration, known concentration. What's meant by known concentration? It means a standard solution. It means the solution that has known amount of the salt or the compound dissolved inside.
it's good to say standard solution. What about this reaction? Maybe the first neutralization reaction. When I say this word, you must know this reaction are used for determination of acids and bases. It's great to know that. Do you think all of them like each other?
No, we have different type of these reactions that may be oxidation reduction reactions, which are used to determine or to determine the redox substances. What's meant by redox substances? Oxidizing agent and reducing agent inside the reactants of this reaction.
It's good to say that. Also, we have precipitation reaction, which are used for determination of substances that form a springly soluble product in the water. Don't forget, all time we play on this word, soluble products in water. This not only, also we have
if the analyze is an acid and the standard solution of an alkali or base, sodium hydroxide or sodium carbonate or potassium hydroxide, any one of these compounds in alkali, so may be used for titration. What's meant by titration here? How can we do this experiment?
We can do this directly if the analyte has some basic character. A standard acid solution is used for titration and so on. So we repeated many times to arrive what we have. Titration. Let's see what we have now.
So here, the end point, we have one of these parts of titration reaction. It's the point at which the neutralization reaction between acid and base is completed and its end.
So we say end point. Now, what about indicator? When we say this word, you must know directly color in acidic medium. This not only, I think we have another one. Do you think that?
Yes, we have the color in neutral medium.
I think this not only, also we have the color in acidic medium again and bases. Now, color in acidic medium. This is the first. Do you think what we have now?
Here we have the color in neutral medium and we have the color of acidic medium and we have another one that's the color of of the basic medium.
Where all of them do you think? Now
Ma equal the concentration and the acid that used mole per liter.
Good. Mole per liter. Do you think what this word it means what?
It means the concentration of the acid that used.
It's good. Now Va equal volume of acid used milliliter. It's great to know all of this, but do you think this is enough?
No, it is not enough.
What we have also?
Here we have another thing. We have Na. It means the number of moles of acid shown in the chemical equation. Concentrate with us very well. Na, it is equal the number of moles. The number of moles of what? Of acid that's shown in the chemical equation.
What about to get titration sodium hydroxide and hydrochloric acid? Look at the figure well and see that sodium hydroxide, hydrochloric acid, titration are used to find the concentration of solute in solution. Titration also can indicate when and otherwise. Understand what? I don't understand this word. Do you think what we have after that?
This is undictable. Dictable reaction is complete. It's what? It is incomplete reaction that happened between the sodium hydroxide and the acid without what? Without indicator. So we have the indicator. We use it here to find out what? To find out the concentration of each one and what? And the volume of each one of the acid and base.
Good. Now fly to this word to find out more. Let's see what happened. Look at this. Sodium hydroxide with hydrochloric acid, when we add it to each other, we can say stage number 1, hydrochloric acid HCl contains a few drops of the colorless indicator. Take care from this. What happened after that?
Here we have the sodium hydroxide and AOH is added 1 drop at 1 drop by the time. So here from the purette above the hydrochloric acid.
After that, we'll fly to the second stage. Second stage, when the indicator turn pink. Oh, from the colorless to pink. This means what? It means
that HCl has been neutralized. Neutralized, it means a complete reaction between the acid and bases here.
In this case, 25 centimeter cube of NaOH sodium hydroxide was needed to complete this reaction. Now, we have an important word. Do you think what is the name of this word?
This word is neutralization.
It means the reaction between
the acid and base, between sodium hydroxide and the hydrochloric acid.
It's great to catch this. Now, we'll fly to stage 3. The test tube turn has it showing that 25 centimeter cube of sodium hydroxide again. So, complete the undictable reaction. This titration can now be repeated without the indicator. Fly to this wall.
Here we have the stage number 4, the neutralization. Solution is poured into a dish and we have heated. After that, the water in the solution evaporated and the sodium chloride crystals form. Why? Because here the end of this reaction that happened between hydrochloric acid and what? And the hydroxide.
Good to say all of this, my dear students. What you have now, this reaction is completed and we have completely neutralization and the crystals appear of sodium chloride. It's easy and wonderful. Now, MB equal concentration of the alkali used. Now, do you think what is the unit for this alkali?
The unit of this alkali is mole per liter.
It's good to say that all time we have a concentration. Directly, don't forget the unit, mole per liter. Fly to the second one. It tell me?
The VB, it means the volume of alkali used. ML, it means what? Milliliter. So, the volume, the measuring unit of volume is milliliter. And we have another one.
And P equal number of moles of alkali shown in the chemical equation. Don't forget the samples because we'll use it for the solving a lot of problems.
We have the types of indicators. What's meant by these types? What are the types and what are the color of each one?
Now we have a different type. As a beginning we have an indicator and the color of acidic medium, also the color of alkaline medium. What about the color for the first indicator will be the first?
First one is methyl orange. The color of this one in acidic medium will be red color, and the color of this one also in the alkaline medium, it means yellow color.
I think this is not only, we have also another indicator. This indicator, it means here phenol, phthalene. What it means, phenol, phthalene. This is very important to note. What about the acidic medium change?
Here the acidic medium, it will be what? It will be colorless. Doesn't it change its color in the acid or in the presence of acid medium. And we have another color of alkaline medium, it will be red color.
Take care now. The red for both the first and second one. The first red in acidic, second one red in alkaline medium. Fly to the other indicator like you see, also acidic medium effect. Third one, alkaline medium. The third one will be
litmus paper. It is very easy to know this. We studied before, litmus paper in acidic medium is red color, and we have in alkaline medium, it's blue color.
We studied many times. I think it's easy. Do you agree?
Yes.
It's very easy. Fly to the important one now. Blue, bromo, thymol. What do you think the color for acidic medium? Fly to important this point. It will be
yellow.
Good. This is especially for acidic. What about the alkaline?
It will be blue.
It's good to say that the blue for both alkaline litmus paper and blue bromothymol. Great and easy. Indicator help me to differentiate between important two. What these two?
Number one, we have the acidic medium and the alkaline medium.
It's good to say that. What about the other one?
Here we have the sodium hydroxide and the hydrochloric acid.
It's good to say that. The equation will be as this shape. Ma by Va over Na equal Mb Va over Mb.
Here we have 0.1. That's replaced by what? By Ma. And we have times what? Times 21. It is the volume of acid, Va.
Good. Don't forget to know Na here it means number of mole will be 1 mole only. What about MbVb?
MbVb divide Nb, we have Mb or M2 here that's replaced by M2. And we have Vb. It's what? It is the volume of base 25. And the number of moles is 1. So it is divide 1.
So when I say why we write it at this M2, because we need concentration of the base. It's easy to say that. Let's fly to this example. The example here will explain, as you see, as a beginning, you have a 20 milliliter of calcium hydroxide solution, CaOH by 2, was titrated with 0.05 mole hydrochloric acid.
So at the end of this reaction, we have 25 milliliter of the acid was consumed.
It's good. Now get it as a steps. To answer this problem as a beginning, you must know what you want. Calculate what?
Calculate the concentration of the calcium hydroxide by mole per liter.
It's good. Mole per liter. Get it at the steps. The solution beginning as you see. As a beginning,
we have 2 HCl in aqueous solution hydrochloric acid plus what? Plus calcium hydroxide CaOH by 2 in aqueous solution also. What are the product here?
We have calcium chloride CaCl2. This it means calcium chloride plus water. This we want to know. Now the rule as a beginning must be right as you see.
So we have MaVa divide Na. A it means relative to the acid.
It's good. This is the first part of the law. This is equal second part directly, especially for the base will be
MbVb divide Nb. B relative to the base.
It's good. Now what about to make replacement for this? The replacement here, Ma equal 0.5 by Va to 25. What about Na? It's 1. The other part will be for the base.
We have M2 or Mb times 20 that replaced the Vb, and we have the number of the moles in the base. We have 2. So it's M2 times 20 divide 2.
It's good to answer this, but you must know something. M2, this is what I needed. Concentration of the base. What about to fly this? Now, concentration of the calcium hydroxide Mb equal
what? Equal 1. times 0.5 times 25 divide what? Divide 2 times what? Times 20. So here we have the last result is what? It will be
0.0312. It means concentration of the calcium hydroxide mole per liter. It's great and wonderful. What about to see the other one? It will be
another example about this. 0.1 gram of a mixture of solid substance containing sodium hydroxide and sodium chloride was titrated with 0.1 molar hydrochloric acid.
Also, we say the complete reaction or the end point takes place by the consumption of 10 milliliter of the acid. So,
we have calculate. I need what? I need the calculation of the percentage sodium hydroxide in this mixture.
it's easy. We need a concentration. We'll fly to solution. As a beginning, we must know the number of the moles for hydrochloric acid that is used. Now we say equal
10 times 0.01 divide what? Divide 1000. Here equal 0.001 mole.
We say 1000 here because we change it from the milliliter to liter. Also, we have this equation HCl plus NaOH. The result directly 1 mole HCl, 1 mole NaOH. Now the answer will be
NaCl in aqueous solution plus H2O liquid.
I want to ask, this reaction can be without this equation?
No.
Do you think why? Must indicate to what?
Indicate to the number of moles in each one of the reactants and the products.
It's good to say all of that. What about to complete the reaction? 1 mole NaCl and we have 1 mole of water. So 1 mole is standard for all equation. Fly to this part. Now,
from the balanced equation, the first one, we have its...
قولها تاني.
From the balanced equation before, it's known that 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid.
1 mole for both. Directly we say, therefore, the concentration of sodium hydroxide equal 0.001 mole per liter. Tell me again what's meant by this unit.
This unit, it means what? It means the concentration of the sodium hydroxide here.
Good to say all of this. Concentration for the piece. Fly to the other part.
We have 1 mole of sodium hydroxide equal 40 grams by calculation. And the mass of the sodium hydroxide in the mixture, we have 40 times 0.001. So it's equal what?
Equal 0.04 grams. Now we have the mass of sodium hydroxide and sodium hydroxide in mixture. Fly to this main point. Percent of sodium hydroxide in the mixture directly will be
0.04 times 100 to get the concentration. Divide what? Divide 0.1.
Directly the answer 40%. Now, do you learn how can you find it? It's easy. The first, get concentration. After that, get a mass. And the final result, directly the percent of the sodium hydroxide.
This method depends on the separation and determination of the mass of the analyte, and by using what? By using
chemical calculation. The quantity of analyte can be measured. 2 approaches are used for analyte separation. Take care, 2 approaches.
Volatilization methods, precipitation method. So we have here 2 methods, like the volatilization method and precipitation method.
Both of them are important for volatilization method. Look the first one. This method is based on the volatilization of the element or compound. Both of them. Why? To be determined, followed by the measurement. Either
by collecting and volatile material and determination its mass, or by measuring the amount of lost amount lost from what? From the original mass of the substance.
Good to say that. This is the important definition for volatilization method. What about the example, the first one? The example here directly are 2.6903 grams of hydrated barium chloride. So when I see this word, you must say it has an important formula. Will be
BaCl2.XH2O. So it is very important example and concentrate with us very well. BaCl2.XH2O was strongly heated until a constant mass of what?
Constant mass of 2.2923 grams of this salt. Now find or calculate the percent of the water of the crystallization of the hydrated barium chloride. This cannot be without equation, and you must make it as a steps. As a beginning, we catch it as
find out the number of water molecules of crystallization. We need this, and write the molecular formula of the salt finally.
This is not only write it as what you must know. O, oxygen, equal mass number 16, hydrogen equal 1, chlorine 35.5, Ba equal 137. All of this cannot be answered without mass number. Now, get it and get the solution step by step. The first solution beginning,
we have mass of water of crystallization equal what? Equal the total mass, it's 2.6903 minus the final mass, it's what? 2.2923. It's equal 0.398 grams. This is the mass of water that evaporated after heating from what? From the salt.
Good. This is water. Also, we have, this means 2.2923 grams of unhydrated barium chloride combined with 0.398 grams of the water of crystallization. When you make the combination between them directly, we will get the percent of the water of crystallization as
0.398 divide what? Divide 14.79% times 100. To get what? To get the percentage of water crystallization, we have what? Equal 2693.
It's good to say that. Also, the molecular formula of barium chloride, BaCl2, equal a mass of the beginning 137, it means barium, plus 2 molecules of chlorine, 71. This is the mass number for both. So the compound result equal 208 grams. All of them combined with
X gram of water of crystallization.
Also, we get it X. This is what I need. How many molecules now? X mass of the water of crystallization in the molecular formula. Catch it as
208 times 0.398 divide what? Divide 2.3. It's equal 36.114 grams. So here, this is the X mass of water of crystallization.
Do you think this is the answer for the problem? This is the end? No. The beginning will be
This means that 2.2923 grams of anhydrous barium chloride combined with 0.398.
It's good to say that. Also, the percent of the water crystallization can be calculated as 208 by 0.398 divided 2.6903. The result here directly by 100 to get percent. So we have 14.79% of the water crystallization. This is important for percent of the water. What else after that?
The molecular formula of the BaCl2 equal the mass of, we have BaCl2, we have 208 or 208 grams. This is the total mass of the barium chloride.
That combined with X gram of the water of crystallization. This combination will result as x mass of the water crystallization in the molecular formula. Now we have
208 times 0.398 divide 2.2923 equal what? Equal 36.114 grams. Concentrate with us very well.
It's good to catch this. Now we know x equal 36.114 grams. We arrive to the end of chapter 2. Are you ready for next one?
We are waiting for you for chapter 3, next session about chemistry. Till we meet in chapter 3, thank you and goodbye everybody.